So, let's talk about what we got. Okay, so we got how about y'all read me the problem and then we'll do the bell work first. Okay, and then what's it asking? Thank you. I say asymptote. Yeah, let's not do that. No. Okay. So we got three things we need to find. So let's look at this. So let's start with domain was first up there. All right, domain. Domain, we take what's in parentheses and set it to greater than 0. So that's 6x plus 4 is greater than 0. Now, that's an inequality, and you need to be able to solve it. When I say solve it, when I say solve it, that means you need to isolate x. You need to get x all by itself. So we need to do certain mathematical operations that are going to get x by itself. So looking at this problem, what's the first operation I need to do? I need to subtract 4 from both sides. Because as long as I do the operation on both sides, it doesn't change the overall value of my inequality. So that's going to be 6x is greater than negative 4. Then next, what's my next operation? Divide by 6. Because I'm trying to get x by itself, trying to isolate x. So if I divide by 6, these two sixes cancel each other out. So now on the left side, I just have x. And then I've got greater than, and then here I've got negative 4 over 6. Now, oh no, it's a fraction. Oh my God. It's fine, it's a fraction. It doesn't matter. But because it's a fraction, you always simplify. There is a number that goes into 4 that also goes into 6. 2. So I divide the top and the bottom by 2. So my answer is going to be x is greater than negative 2 over 3. Done. That is my domain. Now you could also say parentheses negative 2 over 3 comma infinity sign. That right there is domain notation. So either or of these is acceptable for your domain. So now we got x-intercept. So what is the x-intercept? You take the log and you solve it by setting y. Well, let me put set in there. So, yep, you set. So my fault. Let me write that a different way. Okay, let's say you're gonna solve the log and set y equal to 0. So right here, that's going to be 0 equals log base 4 of 6x plus 4 minus 3. Now, the first thing I need to do is get the log by itself. And I need you to understand that, yeah, let's see. This is the log. The minus 3 is something extra. And I can't cancel the log until I get rid of the extra. It's the same principle. Hold on. It's the same principle to where I don't divide by 6 until I get rid of the 4, right? I got x being multiplied by something plus 4. So before I can attack the x and the 6, I got to get rid of this 4. So here, over here, first thing I need to do is get rid of that 3. What do I do? Add 3 to both sides. So now I got 3 equals log base 4 of 6 6x plus 4. And now what's my next step? All right, I'm going to exponentiate with a base of 4. Now, that's a fancy way of saying that what I have there right now is going to become my exponent, and 4 is going to be my base. So I'm going to have 4 to the third power equals 4 to the log base 4 of 6x plus 4 power. Now, the reason that I did that is because 4 and log of 4, they cancel each other out. And that leaves me with my little equation that's up there. The thing is, I'm trying to solve for x. The same way I was trying to get to x over here, I'm trying to get to x over here. But the problem is I got this log that's in the way. So I need to get rid of that. So if I exponentiate, if I make the log an exponent, and the same base that's in the log is the base that I use for my exponent, they cancel each other out. So on the left side, I got 4 to the third power. Nothing cancels out there. I just got to figure it out. What's 4 to the third power? That's 64. That's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So that's 64 equals. The log and the base 4 go away. So that's 6x plus 4. Yep. The next thing is now I just have a standard equation. I'm trying to solve for x. Isolate x. I do the exact same steps that I did for the domain. I subtract 4 from both sides. I get 60 on the left, and I get 6x on the right. And then I divide by 6, the same steps I did up there. X equals 10. That's my answer. I took this base, right there, and made that my base for my exponents. Then I took what my problem had and I made those the exponents. Because when log of the base is the exponent for the same base, they cancel each other out. Because log and exponents are inverse operations. It's the same principle when I got plus 4 and I subtract 4. Those are inverse operations. They cancel each other out. It's the same principle when I got 6 times x divided by 6. Times 6 divided by 6 are inverse operations. They cancel each other out. Exponents and logs are inverse operations. So that's x-intercept and domain. The last thing I got is the vertical asymptote. So what do? I take the parentheses and set it equal to 0. Yes, that'll work. So I set it equal to 0. So that's 6x plus 4 equals 0. And then I do the exact same steps that I did for the domain. I subtract 4 from both sides. I get 6x equals negative 4. Then I divide by 6 on both sides and get x equals negative 4 over 6. Then I reduce. So x equals negative 2 over 3. That is my vertical asymptote. So those are the three things. Okay, I was just showing what I did. Calm down. I said, so those are the three answers. See? Is it okay if I just move it a little bit so you can see all three of the circles? Whatever, man. Y'all should get some eyes and write faster. So anyway, those are the three answers. Does anybody have any questions on those three? Because we still got to do that one. That was number 1. That's not number 2. Nope, I can do number 2. So let's do number 2. What's number 2 say? Thank you. Y equals what? log of 5, x plus 3. Doesn't matter, just hurry up. What? Thank you. Okay. No. So, here's what I got, right? No, I got to finish this. Okay. All right, so let's talk about what the heck that means. This is the parent graph. So what the heck does that mean? Yes. So what does that mean? That means this. So right here, this is log of x. Okay? So that's my parent graph. Now, if I take what was the stuff on that problem? What was it? Yeah. X plus 3 what? Minus 2. Okay, I want you to look at this. Look at the difference between the graph that's red and the graph that's blue. Now, it doesn't matter that that says base 5. The same principle applies. It's doing all of that, but just hear me out. The general graph for log of x, that means there's nothing extra there. All right? That's the general graph, right? Now, what ends up happening is that when I put the graph of log of x plus 3 minus 2, there are two things that happen in there. That plus 3 causes a horizontal shift. It moves it left or right. Then the minus 2 moves it up or down. So the parent graph is the one without all that extra stuff. It's just log of x, like that one. The parent graph right there says log base 5 of x. Now, it's funky trying to put the base 5 in here, so frankly, I don't care about the base 5. It's just generally. The parent graph looks like that. You don't need to know what the parent graph looks like, but I need you to understand the principle that the parent graph just means that it's just the graph with no extra stuff. But the graph that I'm asking you to do, it is a moved graph. It moves. It's the same graph, just moved. Now, what kind of moves did I make? Well, when I look at this graph, the minus 2, look at where the graph is right here and where it is now. What happened to that graph? It moved down. So the minus 2 says it moved down 2 units. It moved down 2 units, right? And then the x plus 3. The x plus 3, I know this is going to be confusing, but just got to say it. It does the opposite of the number that's in there. So instead of moving to the right, which is the positive direction, when you add, it moves to the left. So adding 3 moves you to the left 3 units. So look at the parent graph, right? Matter of fact, let's see if this will work. That's what, 1, 0? Oops. And then let's see, what point is that? If I move to the left, that's -3. So what's that? No, I'm going to show you. Just give me a second. And down to, okay. So every graph generally has the point 1, 0. But look at what happened to that point. That point moved down 2 and over 3. Yes, ma'am. Yes. Yes. Yes, that's the parent graph. So what I'm trying to show you is that the parent graph is always going to have this point at 1, 0. But if I look, that same point got moved down 2 and over 3. So if I'm confused about, okay, what's the graph, I just think about, well, what happened to that point? That point moved down 2 and over 3. So what does that mean I need to do? I just wanted you to understand the principle of what I'm talking about. Now here's what you need to do. I need you to visually see that. Now what I need you to do. What I need you to do is it's a horizontal shift, 3 units to the left, and then a vertical shift. Vertical goes up or down. Vertical shift is 2 units down. That's it. That's what I need. You don't need to worry about the graph. You don't need to worry about the pictures. Not. I think later on I might have you do a matching thing or something. But all I'm asking you to do is I'm saying if this is where I started from and this is the problem I'm giving you, you need to say that this graph is shifted 3 units to the left and 2 units down. That's what I need you to. That's the answer to that problem. I say describe the transformation. The transformation is the graph, the parent graph, move 3 to the left and 2 down. That's it. I needed you to understand visually what I was talking about. So that's visually what I'm talking about. But you don't need to draw it, no. You just need to know. I mean, you can look at this and say, okay, the number in the parentheses is my horizontal shift. Does it move it left or right? The number outside the parentheses is my vertical shift. Does it move it up or down? That's it. Left. You move to the right. Yep. Yep. Okay. Are there any questions on that? All right. Okay. That's bell work. Yo, I'm trying to do more problems now. Do you want me to record them or do you want me to stop? Okay, so then I need to get to it and do more problems. So, nobody got any questions? Let's do some more problems. All right. Yep, I am. Oops. It's fine. I'm not writing yet, so it's fine. I mean, I'm not talking yet. Oh, well, you just got to get over it. X minus 2 plus 5. Okay. No. Let's do something easier. Because that way I can do it to all of this. Okay. So we got this problem. Let's talk about, let's describe the transformation. So my parent graph is y equals log of x. Now I need to say that because that gives us, that means I can do the problem. If I don't talk about the parent graph and I just say what's the transformation, you can't really do the problem. So anyway, that's my parent graph. Couldn't hear a word you said. 5? It's not up there. You said you want me to do some problems. I made up one. I made up a problem. That's why it's not that one. Because the problem has a log of 5, so the parent graph is log of 5. The problem here is log of x. The base there is log. So they got to be the same. If my base is different, then I can't do it. No problem. Okay. So I need to know what my transformation is. So what you got? I know. I'm waiting here. Let's go. I can't hear you. Speak up. Okay. So the vertical shift is actually going up because this is plus. So that's up 1 unit. So you can say 1 unit up or up 1 unit, however you want to say it. The horizontal shift is what? It's not down. Horizontal goes left or right. It's right 2 units. That's it. That's my vertical shift horizontal. Don't care if you write it backwards horizontal then vertical or vertical then horizontal. That's fine. It doesn't matter. which way you write it as long as you do the right numbers. Inside the parentheses, horizontal. Outside the parentheses, vertical. Plus for vertical is going up. Minus for vertical is going down. Plus in the parentheses goes left. Minus in the parentheses goes right. Yes, ma'am. Yeah, I'm working my way to that. Um, what rules? Nope. There you go. All right. Y equals log base 4 of x minus 3/4 minus 0.8. And my parent graph is y equals log base 4 of x. So what do I what's my describe my transformation? Mhm. Okay, so horizontal. Horizontal doesn't go down. Horizontal goes left to right. Okay, we're doing vertical then, my fault. So vertical shift doing what? Say it again. Yep. Vertical shift 0.8 units down. See, the reason I did that was because I don't care if it's a decimal or a fraction or a whole number, because that doesn't matter. All that matters is that you know whether it's going up or down, and that's how many units. 0.8 is not one. It's like a piece of a unit. And then what else? Yeah, 3/4 unit right, or to the right, however you want to say it. What thing right where? Where? Vertical shift was what I was trying to write. This, this, this. I don't know. This log 4. Mhm. Log 4. Sorry, when you were talking about that, I didn't understand. This right here was what you asked me for. You said give you the rules, so there you go. H and K. If my general equation looks like that. Does anybody have any questions on this? Okay. Like I said, look at the video because I'm running out of time. Where's the H what? It's right here. Right there. Right here. That's the H. Okay. Let's go with red. Okay, so let's look at y equals log of 2x um, plus 4. Let's see. Let's just plus 1. Okay. So here's my log. I want to write out the domain, the x-intercept, and the forget that VA, the vertical asymptote. So let's start with domain. Domain, what do I do? Okay. All I do is focus on the parentheses and I set it equal to greater than 0. So that's 2x plus 4 is greater than 0. Then I solve it. Solve for x. So minus 4 on both sides, just like the lady said. 2x is greater than negative 4. And then what? Divide by 2 on both sides. Yes, it will be, and it'd be wrong. Because dividing by 4 doesn't help you. Because I'm trying to isolate x. If I divide by 4, I'll have 2 over 4x. And then that doesn't help me because I'm trying to get rid of the 2. That's why I divide by 2. You understand what I'm saying? Because, see, I get rid of the 4 by subtracting it. So now the 4 is on the other side. Now I've got 2x is greater than negative 4. I need to get rid of the 2 so x is all by itself. That's why I divide by 2. So yeah, if you divide it by 4, it wouldn't help you. So now I got x is greater than negative 2. Or negative 2 to positive infinity. So either one of these is my domain. I'm not asking you to take the extra step to write that. I'm just telling you that's another way to write it. If you leave it like this, that is perfectly acceptable. Okay? So now we got to go with the x-intercept. So x-intercept, what do we do? Well, I mean, generally, what do? We solve the log with y equal to 0. So I say 0 equals log of 2x plus 4 plus 1. So yep, minus 1 on both sides. Right? All right, so now I got negative 1. Ah, shoot, this is good. You know what? Forget that. That's going to make it too hard. I don't feel like doing all that. Let's make it minus 1. Definitely don't feel like doing that today. So we're going to add 1 to both sides. Yep, so we're going to have plus 1. Trust me, you'll appreciate it. All right, what's my base for that log? 10. How do we know it's 10? Because there's nothing there for the base, then your base is 10. So then now I need to exponentiate because exponentiating is going to cancel the log part off. So I have 10 to the first power equals 10 to the log of 2x plus 4 power. So the log and the 10 cancel each other out. So on the left side, I got 10 to the first power, which is what? 10. And then the 10 and the log cancel each other out. I get 2x plus 4. Okay. So the next thing, I minus the 4 on both sides. Right? And so 10 minus 4 is 6. Now see, here's another example. I'm trying to isolate x. All right? So I need to do the opposite of times 2. So I divide by 2. So that's 3 equals x. That's my answer. The x-intercept is x equals 3. That's next. All right, and then the last thing is the vertical asymptote. The vertical asymptote, you said what's in parentheses equal to 0. So that's 2x plus 4 equals 0, and then I solve for x. So solving for x, I subtract 4 from both sides. I get 2x equals negative 4. I divide by 2 on both sides and get x equals negative 2. Those are my three answers for that. All right. Does anybody have any questions? All right. The reason I said, oh no, I want to change the sign, because if that was a negative one, what would I have to do? I had to make it a fraction. And then I would have had a fraction minus 4, which means I would have got some weird looking fraction. And I didn't want to mess with that right now. What's your question? 10 to the negative 1 power. Anything, when the power is negative, it moves its position. So instead of having 10 to the first power be 10, it would be 1 over 10 if the exponent is negative. Yes, that's what I said. If I made this 1 negative, so when I exponentiate, that would have been a negative 1. So that's why I didn't want to deal with that. That is an excellent question. So anyway, um, okay, sure, let's do a problem with it. Say it again. Yes. Okay, I'm not sure what you're asking me. You're talking about that one. What about it? You add 3 to both sides. I guess we got time for one more. Um, okay, so then we gotta go x 3. Okay, let's do this. Okay, so I got that. Let's do the x-intercept. So let's do the x-intercept. All right. So the x-intercept, right? So yep, I need to set y equal to 0 and then solve the log. So 0 equals log base 2 of x minus 1 plus 1, right? What's my next step? Subtract 1 from both sides. So now I got negative 1, it wasn't that. Log 2, x minus 1. Now what's my next step? Yep. Now I exponentiate. I take my base of 2 and make that my base, and then make what is in my equation or my function for the exponent. All right. So now that I did that, like D was saying, these two things cancel each other out. So I'm gonna have 2 to the negative 1 power. Yeah, 2 to the negative 1 power is 1/2. Does anybody have any questions about why that's 1/2? No, because the negative exponent doesn't change. It doesn't change positive or negative for the number. All it does is change position. So 2 to the first power is 2. 2 to the negative first power is 1/2. Say that again. Yes. Okay. Yes. So that's what I got. Does anybody have any questions about how I got to this point? All right, so next, what do I do? Nope. What do I do next? I got to add 1 to both sides. When I add 1/2 and 1, I get 3/2. Or 1 and 1/2 equals x, and that's my answer. So it's either x equals 3/2 or x equals 1 and 1/2. Either one of those answers is acceptable. Yes. Okay, 1/2 is my first fraction, and I'm adding 1, right? I need to change 1 to a fraction. What is 1 as a fraction? 1/1, that's excellent. So I got 1/2 plus 1/1. The problem is, when I add fractions, what do? Like common denominator. So what do I need my denominator to be over here? 2. So how do I make a 1 a 2? Times by 2. So if I times the top and the bottom by 2, I get 1/2 plus 2/2. And then I add together. The bottom stays the same when I add fractions. 1 plus 2 is 3. 3/2. Yes, cuz, what's up? Yes. Where? What's the problem? Yes. Yes. You mean right here? I made it the exponent. That's why I say that fancy word exponentiate. Because log and exponents are opposite. I'm trying to get rid of the log. I'm trying to get rid of this thing right here. I can't get rid of it just because I want to, because I'm trying to get to x. But if I take this base and I make it a base and this is an exponent, they cancel each other out. And that's what I did. Yes, that's what exponentiate means. I started using this is the first year I ever used that word. Exponentiate. So the -1 is my exponent, and then on the other side, my log base 2 of x minus 1 is my exponent. Those cancel each other out. But see, on the left side, they don't cancel off, so I just have to take that. So I take 2 to the -1 power, and I get 1/2. Excellent. Does anybody else got any other questions? Okay, and I'm stopping this. Because this problem started off with a base of 2. Well, you don't gotta be sorry, it's fine. Definitely don't say sorry. Y equals log of 4x minus 5. Um, let's see. Minus 2. Okay. So I need to find the x-intercept. X-intercept says y equals 0. So I've got log of 4x minus 5 minus 2. What's my base? 10. If there's no number here, my base is 10. Don't be sorry, it's fine. So that means that I'm going to set my base on both sides equal to 10, and then what's up there is going to be my exponent. Because my base is 10 for my log, I have to have my base for the exponent be the same so they will cancel each other out. Okay? Oh shoot, I did it too early. I'm sorry, I messed up. Yep, totally messed up. Why you let me do that, Dorian? Okay, so the first thing I need to do is get rid of this 2. So I got to add 2 to both sides. I'm really sorry. So now I got 2 equals log of 4x minus 5. what's important is that the log is by itself. And I totally missed that. So yeah, somebody gonna get that stuff to it's fine. So log of 4x minus 5. That's all the log. That minus 2 on the end needs to go away. So we move it to the other side. And now that I did that, like I said, my base is 10. So that's 10 to the second power equals 10 to the log of 4x minus 5. Okay? And so now on the left side, I got 10 to the second power. What's 10 to the second power? 100. See, I can do that. But on the right side, I've got 10 as my exponent and log base 10 as my log. They cancel each other out. So I just got 4x minus 5. Yes. So then I add 5 to both sides. That's 105 equals 4x. And then I divide by 4 on both sides. I end up getting 105 over 4 is my answer. Because it doesn't divide evenly, so you don't even do it. Just 105 over 4. That's the x-intercept. Now, if I was doing the vertical asymptote, I just take 4x minus 5, it equals 0. Then I add 5 to both sides, and I get 4x equals 5. Then I divide by 4 on both sides, and I get x equals 5 over 4. Again, it doesn't go in there evenly. We're doing algebra, so we just leave it that way. The domain is, yes, it's the same for the domain. Domain, I got 4x minus 5 is greater than 0. I do exactly the same operations, only with an inequality. So now I add 5 on both sides. I get 4x is greater than 5. And then I divide by 4 and get x is greater than 5 over 4. So x is greater than 5 over 4. That's my domain.